Welcome to the Teja Statistics. Next, dual linear programming problem for the paper 8, that is operational research, we are going to discuss. So, every linear programming problem is associated with another linear programming problem. The original problem is called the primal LPP and the other problem is called its dual LPP. The relationship between the primal and the dual is very useful. The optimum solution of one from, that is primal or dual, of LPP reveals the optimum solution of the other. Sometimes the dual LPP is easier to solve than the primal LPP. In this case, one can solve dual LPP rather the primal LPP. Procedure of changing the primal of LPP into dual LPP. Step number 1. If the objective function is maximization, then convert into the minimization, vice versa. Step number 2. The cost vector of the objective function of in the dual LPP is considered from the right hand side of vector of constraints in primal LPP. Step number 3. The constraint coefficient matrix of dual LPP is obtained by the transpose of constraint coefficient of matrix of the primal LPP. Next, if all constraints in the primal LPP are less than or equals to, then the change in dual as greater than or equals to, and vice versa. Next, the various primal dual pairs. Here is, you can see, this is first form of case 1. Next, the second form, you can see, and third form is also be here. The primal against the dual. For the fourth case, you can see here. The fifth case also you have here. Next, obtain one example problem. Obtain the dual LPP to the following LPP. See, max z equals to 2x1 plus 5x2. Subject to the constraints 3x1 plus 4x2 less than or equals to 8. 5x1 plus 6x2 less than or equals to 3. Minus 2x1 plus 4x2 less than or equals to 5. And x1 and x2 is always greater than or equals to 0. In the primal, there are two variables and three constraints. Therefore, dual consists three variable and two constraints. The given primal LPP can be written in the matrix form as follows. Yeah, here is the C matrices is 2 and 5. You can see from the given question. Next, A equals to the matrices and x equals to x1 x2 and b equals to 3 8 5. This is, we are assuming it as primal LPP. Just we are trying to convert the given primal LPP into the duality or dual. So here is the steps we can see here, and we are writing that the dual of the above primal matrix of the form min z equals to B transpose of W, A transpose of W greater than C transpose. W is always greater than 0. Therefore, directly we can see the dual of the given LPP is mean z equals to the B transpose values 8W1 plus 3W2 plus 5W3 subject to the constraints 3W1 plus 5W2 minus 3W3 greater than or equals to 2 and 4W1 plus 6W2 plus 4W3 is always greater than or equals to 5. Very simple and easiest concept, the duality. Next, see the solutions of this. You have a lot of problems over here. The duality theorem. The dual of the dual is primal. Every time they are asking this question, you can write for the long answer also. You can mention the equation, linear equation of the form, and also you can represent them in the matrix form. Then also write the algorithm as like this. Okay, as you can see, the dual of the dual is primal. Simply just see the procedure. That's it. The above proof can also be done without converting into the standard form as follows in the matrix form. Next, fundamental theorem of the duality. If the primal or the dual LPP has a finite optimum solution, then the other LPP has also the finite mean optimum solution, and the optimum values of the objective functions of the two LPPs are equal. So max z equals to the min z values. Very important fundamental theorem of the duality, as you can see the proof also. These are the cases. Just see the problems, the duality concept. Solve the following LPP by using the duality. Min z is equals to 20x1 plus 10x2. Subject to the constraints x1 plus x2 greater than or equals to 10, 3x1 plus 2x2 greater than or equals to 24, x1 plus x2 greater than or equals to 10, 3x1 plus 2x2 greater than or equals to 24. Solution for the given LPP. Given LPP is in the form of the minimization type, convert that into the primal by supposing, and then find out the value of the dual. Here you got the dual. By converting this inequations into the equations form, we got this, and we are representing in the table of the content of that is initial simplex table. Initial simplex table. See the simplex table after applying the row operations and the column operations. Next, here all zj minus cj's are greater than or equals to 0, as the current solution is an optimum solution. So max z will become 120 at w1 equals to 0 and w2 equals to 5. Next, the primal solution also gives the same. Okay, this is how you have to prepare and also calculate. Just do the second problem as your homework. to understanding purpose. Thanking you.